rhombencephalon, part of metencephalon. Metencephalon, at previous class we discussed pons, and today we discuss cerebellum. If we talk about external structure of cerebellum, cerebellum have two hemispheres, two hemispheres, 1, 2, and between contain vermis. This is vermis. I don't know in English. Червяк, vermis, wormis. In English, vermis, because it's looking, maybe like worm. Worm in English, vermis in Latin. So have two hemispheres, and between one wormis. Hemispheres and wormis. And you can see that hemispheres is covered gray matter, cortex cerebelli, looking fovea cerebelli. Between have a lot of grooves, a lot of fissures, and one fissure it's more deep, this, and dividing one hemisphere to superior part and inferior part. So one groove it's more deep, horizontal groove. If I take another, this is fissura horizontalis. This is fissura horizontalis, more deep. Fissura horizontalis. Then the hemispheres of cerebellum have a secondary grooves, very small, and they dividing these grooves. Dividing the cerebellum to gray matter of cerebellum to the lobus, and the most promoted. This is flocculus. This is flocculus. And flocculus. This is flocculus. Flocculus. Then, if we say about cerebellum, it's have the ancient, old, very old, archaeocerebellum, then paleo, more new cerebellum, and new neocerebellum. So firstly, development archeo, very old cerebellum, vestibular cerebellum in Latin. It's contain flocculus and nodulus. It's small lobulus of the cerebellum, and nucleus fastigii. It's gray matter inside. Today I show you. Spina cerebellum, paleo cerebellum, old cerebellum. It's contain vermis, and nucleus globusus and nucleus emboliformis. And new cerebellum, called ponta cerebellum, contain hemispheres of cerebellum and nucleus dentatus. And for function, very old cerebellum only balance function. Then the paleo cerebellum, it's coordination of the body muscles, and the new cerebellum, coordination muscles of limbs. Yes, coordination muscles of limbs. Then, about external structure questions. Then we say, I show you flocculus, and we have second small, it's located in the thickness of cerebellum, it's called nodulus. Flocculus connecting with nodulus have balance function. You know, the cerebellum is the most important balance coordination part of brain in our body. And about external structure, this is all. Then, if we say about internal structure, in the thickness, we can see accumulation of gray matter. And we can, I bring the picture, we're making a section in cerebellum. This is cerebellum, this is section. And we can see accumulation of gray matter. The most medial located nucleus fastigii. Yes, this is nucleus fastigii. Then going nucleus globusus, looking like globus. I don't know globus. Yes. Global. Nucleus globusus. Then more lateral nucleus emboliformis, and the more lateral, the more new part of cerebellum, nucleus dentatus. Yes. Nucleus fastigii, nucleus globusus, nucleus emboliformis, nucleus dentatus. It's accumulation of gray matter formed a free nucleus. Study from medial to lateral. And nucleus dentatus is the most new, connecting with the pons and connecting with the olives. We have tractus alliva cerebellaris, olives connecting with the nucleus dentatus of cerebellum. And else, the gray matter is cortex cerebelli, it's also the gray matter too. And you can see in section, cerebellum looking like a tree, and it's called arbor vitae. Arbor vitae, yes, arbor vitae, looking like it's a tree of life. Tree of life, because looking like a tree. Yes, looking like. This is, you can see, looking like tree. This is arbor vitae. Then about gray matter, this is all. Then we have the white matter. White matter, the cerebellum have three pair of legs. Yes, superior, middle, and inferior. Inferior connecting cerebellum with the medulla oblongata. Middle and more promoted connecting with the pons, and upper with midbrain. So cerebellum have three paired legs, pedunculi. Pedunculi cerebellaris superior connecting with midbrain. No, they located inside. If I open, this is this. Then the most big, this is pedunculus cerebellaris media going to pons, and pedunculus cerebellaris inferior go to medulla oblongata. If I carefully open, this is inferior going to medulla oblongata. So and from these legs passes some tracts. If we called about pedunculus cerebellaris inferior, passes fibra arcuata externa, yes, from medulla oblongata to the cerebellum. Then tractus alliva cerebellaris, olives of medulla oblongata going to the nucleus dentatus of cerebellum, and tractus spina cerebellaris posterior. For function, this is unconscious proprioceptive sensitivity. And descending only one tract, truncus vestibular spinalis, going from the nucleus fasciculus to the spinal cord. So if tract descending, this is unconscious motor tract. Motor descending, unconscious, because beginning in the...
not in the cortex.
Yes, so this is unconscious motor tract. So in total we have 4 tracts in the pedunculus cerebellaris inferior. Pedunculus cerebellaris inferior connecting cerebellum with the medulla oblongata. Then we have pedunculus cerebellaris medius, more big, yes, 1, 2. They connecting with the pons and have only one tract, tractus ponta cerebellaris, from nucleus pointis to the cerebellum. Tractus ponta cerebellaris. And pedunculus cerebellaris superior connecting with the midbrain, tractus spina cerebellaris anterior, and tractus cerebello tegmentalis, going from cerebellum to the tegmen of midbrain. And about white matter, this is all. So, no, about, you can see in the cerebellum, it's not a lot of information. External structure you should know, function, balance you should know, have the very old and new, yes, 3 parts, and what contain gray matter and white matter, and 3 pair of legs. And about cerebellum, this is all. Questions? No, cerebellum have questions. Then we have the isthmus of hindbrain, isthmus rhoboencephaly. What is contained? Pedunculus cerebellaris superior connecting cerebellum and the midbrain. Then we have superior medullary velum cell. Today I explain you where it's located. And trigonum lemnisci, loop triangle. So the auditory tract, lemniscus lateralis, anteriorly located handle of the internal colliculus, next class we discuss, and posterior superior cerebellar pedunculi. Midbrain we discuss at the next class. So, in this topic, you should know in all part of brain, in the rhombencephalon, in the mesencephalon, in the telencephalon, we have a cavitas, like in the spinal cord. In the spinal cord, we have canalis spinalis, where located cerebrospinal fluid. And cavitas of rhombencephalon, this is fourth ventricle, ventriculus quartus. Fourth ventricle. Cavitas of rhombencephalon, fourth ventricle. Rhombencephalon, pons, medulla oblongata, and cerebellum. So all part of brain contain cavity, and in this cavity located cerebrospinal fluid, and all time is accumulate. For ventricle, ventriculus quartus. How it's formed? It's looking like a tent. Tent. Where humans live on the street, make it a tent. Have bottom and tent. Bottom and tent. Bottom, this is fossa rhomboidea. What parts of brain making fossa rhomboidea?
Medulla oblongata.
And pons. Inferior part making medulla oblongata, and upper pons. It's looking, yes, ventricle. It's looking like this, like tent. Yes, tent. This is fossa rhomboidea, pons and medulla oblongata. And this is in English sail. Sail. Velum cerebellaris superior and velum cerebellaris inferior. Velum cerebellaris superior stretch between pedunculus cerebellaris superior and inferior between pedunculus cerebellaris inferior. So this velum stretch between and together making this is fourth ventricle. Fourth ventricle. Ventriculus quartus. Ventriculus quartus. Have bottom fossa rhomboidea and two velum superior inferior stretch between upper pedunculi of the cerebellum and lower inferior. Yes. We have one preparate to show. This is triangle shape. This is yes. This is bottom of fossa rhomboidea. This is velum inferior, velum like triangle looking. Bottom of fossa rhomboidea, velum inferior, velum superior. And you can see in full preparate, I can show you fourth ventricle because it's located inside. And fossa rhomboidea we can see only if we cut and opening cerebellum. So in the full preparate we can't see fourth ventricle because we should open. We can see fossa rhomboidea, pedunculus cerebellaris superior inferior, and between stretch the velum. And together they're making a fourth ventricle. This preparate you should know on the exam. Inga can say you find me all parts of brain and you can show her fourth ventricle. Only on the cutting preparate we can show fourth ventricle. On this preparate, on this preparate, triangle shape have fourth ventricle, yes. And все, наверное. Just on this. No, it's more visible on this preparate. 1, 2, 3. This is fourth ventricle. Bottom. This is rhomboid fossa. Velum cerebellaris inferior. Velum cerebellaris superior stretch. Fourth ventricle. In this place accumulate cerebrospinal fluid, and these cavities have communication, lower and upper. Lower is connecting. Lower, so it's not closed system, yes? Lower and upper, it's open. Lower, it continue to the canalis spinalis.
Spinal cord.
Yes.
Canalis centralis.
So lower cerebrospinal fluid passes to the spinal cord in canalis centralis. And upper is going to aqueductus.
Cerebral aqueduct, mid-brain.
Yes, this is cavities of midbrain. Understand? Aqueductus and canalis centralis. So the fourth ventricle is open. It's got communication lower and upper. Lower canalis centralis, upper midbrain, aqueductus cerebris place called. Understand?
Yes.
Understand. Then what else? And you can see that fourth ventricle have a plate where located three foramen. 1, 2. 1 and 2. 1 and 2. Have medial aperture of fourth ventricle. This is apertura mediana ventriculis quarti and apertura lateralis ventriculi quarti. This is majandi, middle, and luschki, lateral. Yes. Majandi, name study, majandi and luschki. From this place, cerebrospinal fluid going from the fourth ventricle to the cavitas subarachnoidalis. So all time cerebrospinal fluid is accumulate. Yes, cerebrospinal fluid produces in the lateral ventricle. It's part of telencephalon. Then passes to third ventricle, aqueductus, fourth ventricle, and only then to the subarachnoid space. So all time cerebrospinal fluid should accumulate. But unfortunately, if on the some parts it's blocked, maybe you see the small children have big head.
Yes.
But in Russian Vodyanka, when a lot of cerebrospinal fluid located in these ventricles. And in Russian and India, I also think to making operation, special making to this cerebrospinal fluid full out. Yes, remove. Because in normal cerebrospinal fluid all time, yes, accumulate. Introduced in one place, passes down, and then exit from these two foramen to the subarachnoid space to the brain. And about this information, it's all. And in the previous class, we should discuss cranial nerve from 5 to 8. If we tell about cranial nerve number 8, it's called nervus vestibular cochlearis. Nervus vestibular cochlearis. For function, this is sensitive nerve. In common, have 6 nucleus, 6. 2 cochlear, and 4 vestibulate, yes. 2 cochlear for hearing, and 4 vestibulate. And all these 6 sensitive nucleus located in one side. This is in lateral corner of fossa rhomboida. This is fossa rhomboida, and you can see in lateral corner located the regio vestibular cochlearis, area vestibular cochlearis, where located 2 cochlear nucleus and 4 vestibulate nucleus. Nervus vestibular cochlearis for function sensitive, hearing and vestibulation. Next nerve, nerve number 7, nervus facialis. For function it's motor. It have sensitive nucleus solitarius, yes. Nucleus solitarius, then nucleus salvatorius superior, purple, and motor. Nucleus nervi facialis. This is nucleus nervi facialis. And this nucleus making a loop, all see elevation. This is 1, 2. Colliculus facialis. It's loop of motor neuron of cranial nerve number 7. Next, cranial nerve number 6, nervus abducens, only motor, and this motor neuron located inside the colliculus facialis. This is inside the colliculus facialis. And then next nerve, nervus trigeminis, it's mixed, have 3 sensitive and 1 motor nucleus. If we say about sensitive nucleus spinalis, nervi trigemini, then nucleus principalis, nervi trigemini, and nucleus mesencephaly. They going together, 1, 2, and 3. Yes. And the last motor, nucleus motorius. This is nucleus motorius nervi trigemini. So for function it's mixed. 1, 2, 3 sensitive and 1 motor. Yes. And about cranial nerves, this is all. 5 mixed, 6 abducens, only motor have 1, facial mixed, and vestibular cochlearis number 8 sensitive. In common have 6 nucleus, 2 cochlear and 4 vestibular located in the corner of fossa rhomboidea. And fossa rhomboidea and mesencephalon we discuss on Wednesday because you have only one day to study. So study only cerebellum to Wednesday, it's not a lot of information, and cranial nerve from 5 to 8. Like today I ask you number, you say name, function, yes, how many nucleus names, and this is all.
In the isthmus of Lombencephalon, we have to do only the names. No?
Yes, and isthmus
Only
only the
not
names
isthmus.
because some of this it's
We
part of
don't know.
midbrain and explain where, because now we only study
The names.
yes,
Okay.
yes, yes, yes.
Thanks.